Hello. This is Dell 5520 laptop. Let me show you the problem. Take a look at the adapter LED. As soon as I plug it in, adapter LED turns off, which means there is short circuit in this laptop. And adapter protects it because it draws too much current. I'll check adapter output voltage and it needs to be 0 volt. .5 volt is present and it means adapter has disconnected the output voltage to protect the circuit. So I need to unplug the adapter and then plug it in so adapter starts working again. I'll disassemble the laptop and see what the problem is. In these cases, input is usually shorted. B+ is most probably shorted. It might have spread to other blocks as well. I'll disassemble the laptop and check if the board is repairable or not. This is the board. The model is LA8241P Reverend 1.0. It was repaired before. This inductor has been worked on before. What else? There is nothing else. As this was removed easily, it means that the board was repaired before. Let me remove the heatsink and fan.
Hello everyone, today I'm excited to introduce you to Finti, game-changing accounting software designed for businesses like yours. Whether you're running a repair shop, a retail store, or any service-oriented business, Finti is here to revolutionize how you manage your finances and operations. Join me as we explore the key features that make Finti the go-to solution for small to medium-sized businesses. Efficient repair shop management. Let's begin with repair shop management. Finti allows you to seamlessly handle device repairs. Imagine printing receipts with just a click or sending eco-friendly text messages to your clients automatically. No more hassle, just efficient and organized repair shop management. Invoices and financial transactions. Creating invoices and tracking financial transactions have never been easier. Whether you're issuing receipts or managing expenses, Finti simplifies the process. Plus, if your team works on commissions, Finti's got you covered. Set commission percentages effortlessly and let the software handle the calculations, providing you with detailed reports. User-friendly tutorials. Now let's talk about how to use Finti. Finti is designed with you in mind. Accessing tutorial videos is just a click away. Whenever you have a question or need guidance, simply click on the red icons within the software to watch related tutorial videos. And if you need assistance, feel free to reach out to our support team. They are ready and eager to help you whenever you need. Online accessibility and global currency support. With Finti, flexibility is key. Access your account and manage your business from anywhere, anytime using your smartphone or laptop. And guess what? Finti supports over 20 major world currencies, ensuring users from around the globe can easily navigate and utilize the platform. Don't see your currency? No problem. Our support team is here to assist. It's customized to suit your business. Whether you're in the repair industry or looking for top-notch accounting and inventory management. We can even disable features you don't need, providing a personalized experience just for you. In conclusion, Finti is not just accounting software. It's a business companion designed to simplify your operations and boost your efficiency. Join the global community benefiting from Finti's powerful features. Subscribe now, use the exclusive 50% discount coupon, and let Finti elevate your business to new heights. Thank you for watching and happy managing.
A screw wasn't screwed here. It's another reason to know the board was repaired before. Board needs to be carefully checked. Anywhere that was worked on as suspicious. As you see, the solder on these inductors shows that this block was worked on before. Look at this capacitor. It's obvious that it was worked on. These USB ports were removed. Let me remove the tape. MOSFETs were worked on too. My customer said this board wasn't worked on before. But as you saw, many blocks were worked on. I'll set multimeter on ohm mode. It's better to place red probe on body and then ohm check it. I'll start from this inductor, which is probably for B+ input. Ohm value is not stable. I need to check the board schematic. But first I'll check ohm of these inductors to see what the condition of this board is. 13 ohm. OL appears. OL appears for this too. Let's see if GND is connected. Oh sorry, this wasn't GND pin. Or my multimeter can't show it correctly. Let me check GND somewhere else. Yes. As you see, it's completely shorted. The inductor that was previously worked on. You need to start from the parts which were worked on. I'll check these inductors too. This is 9 ohm, which is so low. This is 10 ohm. I need to check board view or schematic to see where they belong to. It is 0 ohm. So it is shorted too. 0 ohm is a sign of problem. I'll check the other side of board too. CPU power inductors usually have very low ohm values. 2 to 3 ohm can be considered normal, but if it is 0 ohm, it's suspicious that it's shorted. I'm checking this block that was worked on before. Ohm value is proper. It's normal here too. They are most probably 3 ALW and 5 ALW. And as input was shorted, they thought 3 ALW and 5 ALW were problematic. That's why they worked on them. Ohm of this part is fine. This is fine too. This is 3 ohm, which is so low. 192 ohm. I need to check board view or schematic. And check these again. And see where the inductors with low ohm belong to. And see if this board is repairable or not. Two inductors had low ohm. One was this one that was 0 ohm. And this one was 3 ohm. I opened both of them. Now I'll check again. This pin of inductor is open. 6 ohm appears. 3 ohm. This pin has high ohm. This is consumer side, which is graphics chip. 3 ohm is suspicious for the chip, but I can't tell for sure that it's problematic. But on the other hand, I can't tell it is fine either. It's just suspicious ohm value. An inductor in this block was shorted before. This is consumer side. It has high ohm. And this side is the input. Probes can't be placed properly. It is 0 ohm, which means it's shorted. It is connected to this part. By searching PL202 on the schematic, I found out that it was B+. In fact, the upper pin is B+, that I'll show on the schematic. PL202. This is the inductor. This side is B+, and this side is its consumer. Consumer side has proper ohm value, but the other side of the inductor is shorted, which means B+ is problematic. Let me show you the other side's inductor. It is PL500. I'll show it to you. Sorry, it was PL800. VGA_core is here. Chip side was 3 ohm. And this voltage generator side had high ohm. So it's suspicious and I can't make sure if it's failed or not. So now we know that B+ is shorted. I checked all blocks. As B+ is 0 ohm now. So either the low MOSFET of PWM is shorted, or capacitors in B+ path are shorted. Either way, it's unlikely that applying voltage would damage the chipset. If high MOSFET is shorted, low MOSFET is definitely shorted too. That's why it's exactly 0 ohm. So I'll apply 2 or 3 volts to B+ and check which component will overheat. I'll do that now. I set power supply on 3 volt. You can see it on the multimeter. I'll place it here. 3 volt lowered and around 5 ampere is being drawn. I'll use thermal imager and find the problematic component. That block, the block that I'm applying voltage to, is overheating. Let me spray here. The problem is in here. So I need to check components of this block. This block was worked on before. And there is a spot on this capacitor. Even though I don't think it could be seen even by zooming in on it. I'll zoom in. I'll remove this capacitor and check if problem would be solved or not. In order to work on the capacitor easily, I moved it and then soldered it on the board. I'll check ohm of B+. Yes, B+ short circuit is solved now. Let me check this capacitor. The capacitor is shorted. Shorted capacitors is a common problem in motherboards. And by plugging in an adapter, adapter voltage gets disconnected. And they usually burn first or second MOSFETs of charging circuit input. So they need to be checked too. I'll check first and second input MOSFETs through schematic, and we'll see if they're fine or not. Let me search PL101. There is charging circuit here. PQ101 and PQ100 are first and second MOSFETs of charging circuit input. These are PQ101 and PQ100. I set multimeter on diode mode. High number on this way. Now I reverse the probes. 0.200 to 0.700 volt is normal. It's 0.509 volt, which is normal. And this is gate pin. I'm checking source and gate pins together. Drain and gate pins together. As you see, gate pin is not shorted to source or drain. The next MOSFET. It's the second MOSFET. Source to drain is 0. Second MOSFET is burned. The one that was worked on before. Yes. I need to change this MOSFET. The second MOSFET is P channel. A04409. Let's check its specification. It is a 30-volt P-channel MOSFET. The main specification is here. This is ohm value of the MOSFET. When gate source is around -10 volt, this would be drained to source resistance value. I need to compare these values with a similar MOSFET. I have a scrap of this board. Let's see if input MOSFETs are working or not. No, this MOSFET is out of order. And there is a spot on the board. Now I'll check the first MOSFET. Both are P channels. So if the first one is working, I can use it. It's not shorted on this way. This MOSFET is most probably fine. I can replace this MOSFET, which is A04407, with A04409. Let me go to its datasheet. Let's check its specification. 30 volt. Let's compare it with the previous one. 30 volt and -15 ampere. 12 ampere. Current is not much different, so I can use it. It's not too different. Let's check drain source resistance. Drain source resistance is lower than 7.5 milliohm. It is lower than 11 milliohm. It's not so close, but it won't cause any problems on the input, because it is used as a switch on the input. and it is not used as PWM circuit on the board. What it does is to connect and disconnect input voltage. So in these cases, you can use a similar P-channel MOSFET, even if they have different drain source resistance. You don't have to be so sensitive about it. So I'll replace the second MOSFET with the first one. Let's see if the second problem of this board will be solved or not. Pay attention to the direction of the MOSFET. That's it, it's finished. I changed the MOSFET. I placed this inductor in its place. I placed this one back in its place too. Let me check ohm before plugging in the device. I start from input. It is 133 kiloohm and it is proper. I check B+ now. It is over 40 kiloohm, which is normal. I already checked the inductors. This one had low ohm, which is proper now. This is connected to B+, and it is more than 30 to 40 kiloohm now. This is inductor of graphics chip. It is still 3.5 ohm. It is probably because the chipset has low ohm value. Other blocks were fine. As I removed CPU, high ohm should appear. Capacitor charge causes the ohm value to be different at first, and then it goes up again. I checked 3 VALW and 5 VALW before. And this part. It is probably RAM ohm and it's normal. Now I place CPU and plug in the device. You need to pay attention to direction of the arrow and the mark on CPU. It can easily be placed. Let me plug in the adapter. This is the adapter which protected voltage. It is fine now. It is plugged in. It's not protecting anymore. Let me check voltage now. 5 volt is fine. 3 volt is fine too. The rest of the voltages should be checked when the device is switched on. Let me place the heatsink. I temporarily fastened these 2 screws. Let me see where the power button is. I should connect pin 3 to pin 4 of this connector. This is pin 1. These are pin 3 and pin 4. Device is on now. Now I check voltage of the board. I start from input connector. 20 volt enters motherboard. 20 volt is present on B+. 0.8 volt is present on this inductor. This is VCCP and it's 1.05 volt that enters PCH, and it was problematic on the scrap board. So if PCH chip of that board gets changed, it would solve the problem. Along with the input MOSFET, which needs to be changed. This is 1.8 volt. This is B+. It is around 20 volt. One volt is present here. This is graphics voltage, which is 1 volt. This is VGA_core, which is 1 volt too. I need to check what blocks it belongs to. This is related to CPU. 1.03 volt is present. 0.9 volt is present. These are different phases and voltages needed for CPU. This is 1.5 volt RAM voltage. And these are 3.3 VALW and 5 VALW. All plug in the adapter. I temporarily assembled the laptop. It turned on automatically. And image appeared. I just realized that the second problem of this laptop is funnier than the first one. Battery is connected to the laptop. I changed its RTC battery, but right after plugging in the adapter, laptop turns on automatically. This problem usually occurs because RTC battery gets drained. But even though this one was full, I changed it. I also placed the battery on the laptop, but laptop turns on right after plugging in the adapter. Which is a problem, and I need to see why it happens. Take a look. It starts working after a few seconds. It turns on and image appears. This is how motherboard turns on. By plugging in the adapter, 3 and 5 volt get generated. 3 volt enters power button. And by pressing that, I/O realizes motherboard is switching on. And sends PM power button signal to PCH. PCH is a little hotter than usual. Now we need to check if it turns on or not. I should see which I/O pin is related to power button. And check if its voltage changes or not. And also check I/O output and see if it gets high or low or stays normal. It should be 3 volt, and by pressing power button, it should be 0 volt. If these steps weren't performed, the problem can be PCH or RTC circuit. But if I/O caused voltage to be low, the problem would definitely be I/O. If the problem is on the previous steps, the path of power button would be the problem. So I'll check power button signal on I/O. I'll use schematic to find it. I'll search power button. The name might be different on this board. Let me check power connector to see its name. JPWR. The name is on, off BTN. It enters power on circuit. I should check it and see if the problem is power on circuit, I/O or PCH. I'll check this part and we'll find the problem. So now we know, on/off button signal enters on/off button circuit. And then on/off signal enters I/O. Then PBTN_out signal gets sent from I/O, which is for switching process. So now I'll check them. On/off signal is present on power button, which is 3 volt. And as soon as I press power button, it turns on. It got low for a second, then got high and laptop turned on. And image appeared. I'll turn off the laptop. As you see, on/off signal is 3 volt now. I unplugged the adapter. Now I plug it in again. Take a look at signal. On/off button signal didn't change. And laptop turned on. So now we made sure of power button, connector and I/O input. They're not the problem. So it can be I/O, I/O output or PCH. I/O output, which is PBTN_out, is on pin 106. This is pin 96. Pin 100 is marked. And this is pin 106. Now that the laptop turned on, it got high. So I did some stuff on the board. I tried to program I/O, but it couldn't be programmed. I even changed I/O, but it didn't help programming it. But then I realized something. Let me tell you what it was. When I plug in the adapter, it still turns on automatically. Take a look at the fan. And when I remove this mini board, it won't turn on automatically. So this means this board is not the problem, but it's in here. So the first thing I did was that I removed the wireless card, but the problem remains even without it. So it can be audio IC or these ICs. I'll remove them one by one and find the problem. I removed the network IC, which was in here. And that solved the problem. Let me show it to you too. I'll plug in the adapter. It doesn't turn on automatically anymore. So the problem was the network IC. So in laptops with automatic switch problem, one of the reasons can be problematic ICs, including audio or network ICs, which causes the laptop to turn on automatically as soon as plugging in the adapter. So I'll change this IC. I solved both of the problems, meaning power voltage and automatic switch problems. That's it. Produced by dr-bios.com.